Welcome to this episode of the NewSpace India podcast, a bi-weekly talk show that exclusively talks about India's space activities. Model rockets are a great way to learn about spaceflight. Model rockets help people of all ages understand some of the most important principles of spaceflight. In most of the advanced spacefaring nations today, you will find an extremely mature model rocketry ecosystem which allows access to model rocketry to school children and people of all ages. Yet, in India, even though we've had a rocketry ecosystem that lasts for hundreds of years, starting from Tipu Sultan, we haven't had the opportunity to build and scale a model rocketry ecosystem that can inspire hands-on education to our young people. In this episode of the NewSpace India podcast, I speak to Divyanshu, who studied at the Indian Institute of Space Science and Technology, a premier academic institution run by the Indian Space Research Organization, and eventually started his own company to make model rocketry accessible to everyone in India. Welcome to this episode of the NewSpace India podcast.
Yeah, thank you, Narayan. It's great to be here. I usually listen, so I don't really listen to podcasts a lot, but I've been listening to the one that you've been doing. It's been very interesting. Rather, it's making me explore other podcasts as well. So it's been fun, and I feel that it's fun to have connect with a friend again, and we've met after a long time. Hoping towards a great conversation.
Yeah, thanks. I've known you for almost the last 6-7 years, and you've done quite a lot of things in the ecosystem already. So tell us a bit about what was the beginning. How did you get passionate about space? What got you hooked into it, and how you entered the Indian Institute of Space Science and Technology?
So it's actually quite interesting. I always wanted to be connected to space. Even as young as kindergarten, I wanted to be an astronaut. At that point of time, I got glasses when I was very young. I was 8 or 9 years old. And at that point of time, I knew that if you have glasses, you cannot become an astronaut, because only Air Force officers used to be astronauts. And Air Force, as everyone understands, they have their own fitness tests for eyes and stuff. So that's where the sort of dream for rocket science began. Obviously, there were always the questions of career and how it would work. The first step seemed to try and get into a good engineering college, IIT, since I was in India. Luckily, after giving my IIT JEE, actually, after the results and everything, I found out about this college called Indian Institute of Space Science and Technology. Researched a little bit more about it and found out that there's no alumni up till now.
Just let me interrupt you there. So how did you find out that there was this IIST?
I got my counseling brochure from IITs, and they had a brochure of IIST in that, and they had given details that if you have qualified JEE, you can apply for IIST as well.
Okay.
So that's how I sort of found out about it. I didn't know that the college existed before that. And that got me super excited, because I was trying to choose streams which were very, very close to aerospace if I could get it. And my rank, I wasn't sure that would happen. And this opportunity really got me excited, because on paper it seemed like I would get through, and I would. So I wanted to check out the college, and there were lots of interesting things about IIST at that point of time. It's any student who's applying for IIST now, and what I applied to, or actually I would say the first 2-3 batches up till, say, my batch, maybe one batch after me, we had a very, very different experience when applying to IIST. So there was no alumni, there was no campus, and there was no fees. And the people who were involved in the college at a very, very day-to-day level were these amazing high-level ISRO scientists like B.N. Suresh, K.N. Nayanan, Radhakrishnan, even Kalam sir, for that matter, used to sort of visit. And that's the feedback I got from the students who were studying there, when we went for the counselling, we also saw that the counselling was happening in a 5-star hotel, because there was no campus, and the other things were happening in actual ISRO campuses in VSSC. When they showed us the labs, these were actual ISRO labs in VSSC that the students were using at this point of time, because there was no campus. So it was a very, very different experience, and it was, I think, an opportunity that was open for a very, very short period of time. Because now if you go to IIST, it's a full-fledged college, it's an academic institution, and it's not really as integrated into ISRO as it was earlier. It's an independent center of sorts now. It has its own labs, it has its own faculty. The teaching is not really being done by scientists anymore. I wouldn't say that's a bad thing in terms of an academic institution. As an academic entity, they are doing much better now, and they're actually creating more value. Especially over the last 1.5, 2 years, they've started really getting into their groove. So that way, I'm very happy for my alma mater. But I would say that those first years of IST, they were a different experience, and that's something that's logged in time.
So now you're in this environment with all the ISRO scientists and many other potential future ISRO scientists together. Yeah. And so the dream was just that you study there and then get into ISRO, or?
So that came as a jarring shock actually after I got into the college. So up till the point I was a student in school, and ISRO seemed very, very exciting, and it seemed something that I would love to do. That's the full zeal that I had when I was joining up in the college. But that dream, or that sort of image for me personally, was shattered very early in college. I would say as early as first year itself, where I at that point of time had decided that I would not continue to work in ISRO. I didn't feel that it was the kind of work environment that I was suited for. That is not to demean their work in any way. They are doing exemplary stuff, and some amazing people are doing this stuff, but it's not really what kind of not really the kind of environment that I thrive in. It's highly bureaucratic, that like is any national space agency, and then it's a slow work environment. There's a lot of procedural stuff involved. Decision making is by committee and not by merit. Even promotion is by age, and sort of like, you're not even eligible for an SD promotion as from an SC until you worked for 4 years.
Yeah, so this was like, after you've already entered ISRO.
No. This was when I was in college. I found out about all of this when I was in college, right?
Okay.
So all of these things sort of shattered my mindset in terms of I didn't realize I wanted to work in a very, very fast-paced work environment. That had been my problem throughout school as well, where I don't really connect to so slow systems. Like I tend to be an outlier, and so I've had my own sort of rebel modes. Like I quit school in 11th class for a year, and I wasn't going to school. I gave my boards in 12th class in open board because of that. I was suspended from every academic institution I was ever in.
I hope not from ISRO.
No, yeah, he's from IST as well.
Okay.
So I don't really do well in systems. I need to sort of be moving at my own sort of in my way, and I sort of as a child, it's difficult to come to terms with that. You really don't understand it. But as I grew older and I could sort of take more of my own decisions, I started understanding that this was not really the work environment that was suited for me. Even if I do get interesting work, which in itself is very, very rare, I would not survive or thrive. So that way I had decided that I wouldn't really stay within ISRO. I didn't take my studies very seriously. Instead, I concentrated on doing other things in college. So I ended up setting up the first MUN of Kerala State at IST.
What is that?
The Model United Nations that happens. So the one that I set up was the first one in Kerala.
Okay.
And I set it up at IST. It still happens every year. I was the first student who actually started building model rockets in college. I built about 72 of them. The first 72 of them failed. Total, we built about, say, 90, 95. Some last 17, 18 succeeded. So we could have achieved success earlier, but there were a lot of things that everyone does that we didn't want to do. For example, everyone does sugar motors. We didn't want to do sugar motors. Everyone does PVC based tubing for strength and whatever, but we didn't want to do that. We wanted to have lighter materials and stuff like that. So because of that, our success was sort of delayed.
So when it comes to your stint after IST, so did you end up at an ISRO campus, or?
So I was there at ISAC. I was there for about 11 months. The first few months I was mostly getting to understand what is happening and how it works. I was there at Spacecraft Mechanisms Group in ISAC Bangalore, and first 4-5 months I was just trying to understand what happens. And people more senior than me, they used to sort of, whenever they used to do the necessary simulations and stuff. So in Spacecraft Mechanism Group, I was specifically working on the side of simulation of hardware, where we were doing some FEM analysis and all. So the first few months I was just sort of studying how it works and what needs to be done. I used to work on the code's bugs and stuff, mostly just make sure everything is running smoothly in terms of an operational sense for the computing. The next few months, I got a few design problems to tackle on, where I started doing the design for the deployment mechanism of the rover on the lander.
Of the Chandrayaan mission.
The Chandrayaan 2 lander. I am not aware if those designs were used or not, because I'm not there anymore, and I'm fairly sure that things would have changed. It was a very, very basic top cut line design. There was hardly even a complete level of material selection done. We were not even sure what kind of cords we would be using. There was a mechanism involved where we needed a servo motor for the deployment of the ramp. I think that part is still there, but at that point of time we had not decided. So we arrived on basic top line specifications. So that's what I was sort of working on for the next 3-4 months, trying to understand what would be the best way to go about it, what are the materials available, what would be the constraints of the system, and so on. So it's just one small subsystem that I got to sort of study. I was very lucky that I got pure technical design work. So like all my friends around me, there were so many of them who were in divisions and departments where they did not get that kind of work. Like most people are QA and QC, because that's something that's very important. They don't get design work. They have to go through the same grind again and again. Whereas design work is sort of interesting. It's new and it's exciting. Yeah. So that way, those 4 months were a lot of fun. But as I said earlier, it's not really the work environment for me, which actually I realized even in those few months there.
Yeah, so at what point of time did you think that I'll quit ISRO now?
So I had decided at college itself, but after 11 months there were two things that happened. One is that the 1 year mark to me seemed like a sort of a, premonition or like a thing in itself. I didn't want to get there. Apart from that, I was trying to do model rocketry, as I told you earlier also. And at that point of time, I found out that there's a possibility of finding a partner who would be willing to provide us his manufacturing facilities to do testing and product development and so on. And that was pivotal for us, because that would provide us the first commercial place where we could sort of look at manufacturing these things. And up till now, model rocketry had just been a hobby, and I had not really explored how much of a business could it be. I had obviously tried to talk to a lot of people about it, because I found it very, very fascinating. But this is the point I decided to go ahead and sort of make it happen. And primary reason was that even at IST, I found it immensely difficult to build a model rocket. And I felt that what about that kid who wants to and who doesn't have access to what is IST? IST was superb in terms of providing me things that I needed. So that way, it seemed like a problem that was there. It seemed like a gap in our space education system as well. So we have a lot of awareness and outreach and education programs centered around astronomy and astrophysics. A lot of people doing telescope stuff, night sky watching, a lot of educational tourism around space, where people are taken to NASA, they interact with the people who are doing stuff in space. Now even ISRO has sort of started creating its own outreach. But there is absolutely zero model rocketry. Even satellite side things are happening, but there's absolutely zero rocketry ecosystem in India. And as a country who's such a major space power, I thought that it was a gap. And it's much less visible 6 years after, but at that time in 2014 it was a major gap. Nobody had even heard of model rockets and amateur rockets. There were less than 300 rockets flying across the country. And it seemed like a gap that I wanted to change, so I quit and I started working on Rocketeers full time.
And so when you quit, you were alone, or you had some other people who wanted to?
So the Rocketeers, obviously, it started off. So I had a friend who was also my partner in my endeavors during my college time. So we used to sort of do the project together. He was still working in ISRO. So I thought that he seemed like the right person to sort of start that with. But I was a little, I was a college student. I had just started working. I didn't understand entrepreneurship that much. And friends may not be the best co-founders every time. So I did start with him. We tried to do some things over the next 8 months. 8 months later, I sort of realized that things had not worked out. My part of job, even though it was happening, so I was supposed to do the sales and he was supposed to do the product development. And the product development need to happen really, really rapidly, because if we don't have a model rocket that's reliable and safe and stuff like that, then it's pointless. Then we are doing what is a Diwali rocket, and it's not. I need every rocket to perform the same, and so building 5 model rockets is one thing. 10 model rockets is one thing. They may perform the same. They may fly straight. They may be stable. Building 10,000 or 1 million or 10 million of them, completely other ball game. Especially on the fuel side, replicating the fuel cartridge is very, very difficult. And he was sort of supposed to do that. He didn't really fulfill his roles. He didn't even quit his full-time job, whereas I had to do this. I was the one who was investing all the money as well at that point of time. So that sort of fell apart in about 8-9 months. Then it took me about 2 months to regroup, and that's when so Akash had been helping us out in college and during this time as well, but he had never really been fully involved. And this is when Akash sort of fully came on board, and sometime around November, December 2016, we sort of properly started it again. That's when we registered properly, and Akash started working on the product development, and I again started working on the sales.
And which center was Akash in when you were here in Bangalore?
LPSC in Trivandrum.
Okay. And so he moved, or you moved there? Or?
No, so we both moved to Bangalore,
Uh-huh.
and we started doing this. Up till then, I was also in Ludhiana, where my parents live.
Okay.
So that's how we started it again.
And so for him also, the risk was then worth it, the reward, and he was also...
Yeah, so he was definitely very excited by the idea, and he found that... So I was very, very passionate about doing this, and I was ready to bear the financial risk. The other parts of it, there are lots of other risks as well. One puts their career on the line. So those things he was sort of very, very comfortable with. And not that he didn't want to put in money, but then everyone does what they have is possible in their resources. That way, my parents have supported me immensely. They are the ones who are really backing my dream. And luckily, my college was on 100% scholarship. So also, like, I had a lot of scholarship years during school as well.
Mm-hmm.
So I'd saved a lot of education money. So that helped.
Yeah.
So that's how it sort of began again.
Then you register Rocketeers, you start...
So we started doing rocketry again, and the first thing that we did was we set up a manufacturing facility in Sivakasi.
Mm-hmm.
We again had a new partner there. Things with the Nagpur partner had fizzled out because we had not been able to perform, we had not done anything. There's only so much time that any partner sort of supports something without any results, right? So we got in a new partner, we started doing stuff in Sivakasi. Our first proper sales in 2016 started happening again around April-May 2016. For the first at least 14 months, we were sort of trying to just make things happen. There was no profit involved. So we didn't have a lot of money to do product development. All our money was going into manufacturing. And this was the time that I also sort of got into my groove as an entrepreneur, where I had learned a lot of things over the last 2-3 years. I'd read up a lot. I'd read up all these books on entrepreneurship. I'd read up all kinds of resources off of wherever I could get my hands on, and started understanding business and things more. Then sometime around April-May 2017 is where we arrived at a position where we had saved up some money from all the sales that we had made, all the even after manufacturing, all our overheads, everything, and we poured that into product development stint for 3 months, where both of us just got down into our manufacturing unit lab environment of sorts, and we built our own manufacturing system for fuel cartridges. Explosive regulation is a major problem, and it doesn't allow electric connections in explosives unit of a certain kind, and that's the fuel that we're using, black powder. So you're not allowed electric connections, and so that is why most of the black powder products that we see in our country, they are handmade, human made. There are obviously hazard safety measures that you can take, but at the same time it does put human lives on risk, which I think is an outdated system, an outdated way to do things. We could sort of move on from that, but that's another discussion. What we did was, keeping these constraints in mind, we developed a semi-automated manufacturing system where most of the things were hydraulic, manually operated, but the forces were measured, the pressures were same, the movements and the materials that are being used are measured, and so it became a proper system. So every cartridge churning out of the machine became standardized, and that's that's when things sort of started changing for us, and we started scaling up also a little bit in terms of our sales. And 2016 December is when we started this, and I earlier said 2017 April, that was 2018 April. So this was so by 2018 November December, this system started working very, very well. And in January this year, we released the first complete range of indigenized model rockets, fuel cartridges, ignition systems, and the propulsion test stand. Just to mark that in terms of pure business, the revenue that we've earned over these last 8 months is more than the revenue that we did in all of our years before this.
Okay, so let's talk also more about the challenges in the process of establishing all of this, right? So when you talk about model rockets, and to be able to scale and build rockets, and for them to perform it's the same way, what are the challenges?
So obviously there are a bunch of technical challenges that come in. Black powder is made out of very so one of the materials that we're using is charcoal, which is a natural material. Since it's very dependent on the crop, it's a little different in its terms of properties every consignment. And so what we have to do is that we have to sort of build a system which recognizes that, is able to test that, and is able to tweak fuel accordingly in real time. Apart from that, minor structural errors in the curing of this propellant makes properties vary drastically. So that is another sort of challenge that comes in, which we had to put in a lot of brains in. Another challenge which was posed again by regulation is that we cannot have a commercial product. So this is not applicable to defense products, but we cannot have a commercial product, which is a civil product, which has black powder in contact with metal above 3.5 or 4 grams, I think is the limit. So 3.5, 4 grams works for bullets. So anything beyond a bullet, you cannot sort of do that as a commercial product. And that, so we can't build fuel cartridges which have a casing which is strong. So the material that we have to end up using is a variant of paper. It is a paper at the end of the day. It's called cellulose fiber sheet. So this is a high BF sort of high strength paper, and we roll it up into tubes which are bonded with a phenolic resin. So we developed all of these things from scratch, where we found these materials. Now we are manufacturing at a very odd scale. Neither are we lab level nor are we industrial level. So what happens is that in a lab I can make 10 tubes. If I go to an industry, he will want an order of a minimum of 1 lakh tubes. Like 1 lakh tubes is a minimum order. It's a small order for him. About average size order would be 7 or 8 lakh tubes. I want an order of 15,000. So it doesn't fit, and there are no vendors who sort of do stuff like this. So I literally had to go into these vendor units, learn how these things are being done, develop manufacturing systems which can suit my needs, and establish them and put them into place. So the whole supply chain for us had to be done from scratch for each and every aspect like that. This includes the casing for the fuel cartridge, the fuel materials, the raw materials of the fuel, the raw materials of the nozzle. The raw materials of the nozzle was a battle in itself. For the longest time, we found out this material that was in use as a strengthening and drying agent in linings of sort of kilns and stuff. So industrial kilns, they use it in lining, and it is called something different in every language. And the vendors and the sellers and the users know only that name. They don't know what is the technical name of the material. So for us, the longest time, it used to work in our application for almost 4 months. We used to call it Material X. It was our Chemical X, just like Powerpuff Girls. We literally had it written on our board because one of the major agendas was finding out that what is the technical name and how we can modify this material. And we were so things like that happen. I mean, now we know. It's a specific type of wax, and it doesn't look or feel like a wax. It's a liquid wax at room temperature itself, and it can be heated to cure it. So it's high protein. So things like that happen, and the rocket part of it is then easier. The rocket part of it was more of a cost challenge. So when we started off, the cost of building one model rocket in India from scratch was approximately 9,000 rupees. This includes the launcher and the ignition system, but doesn't include fuel. That was the cost for a general customer. Today we have already brought it down to about 1700 rupees, including launcher, fuel, rocket, everything. So the rest of the rocket, except for the fuel cartridge, is much more of a cost challenge, and that as we scale up, we'll obviously bring it down further. And the idea over here is to make it accessible to as many people as possible. A lot of people ask me how big are the rockets that Rocketeers sort of. It happened today in front of you. Aditya was there. The first question that he had was, how big is this rocket and how high does it go, right? And in people's mind, bigger, better. Higher, better, right? In my mind, no, that's not how it works. In my mind, I don't want to build 5, 10, 20 big rockets. I want to build 100 million small ones.
Yeah.
Or maybe 1 billion small ones. Because that's what will make it accessible for every kid in the country, and that's what will make science and technology and space science and technology exciting for them. And that's what will make them connect to learning technology more than anything else. And this applies to a lot of other tech products within STEM education as well. For example, drones or planes or gliders. You were discussing about glider competitions, even robotics. But I feel that rockets have a charm of their own, and it's a much lesser explored area than most other things that we do, especially when it comes to stuff like Baha SAE or gliders or planes. These are things that we have already peaked at. Boeing and Airbus are building amazing passenger vehicles. They may be facing difficulties right now in the moment because of the Boeing 747 MAX, but otherwise they've done very well over the last few years. Same thing happens for cars. We have perfected refinement of cars a lot. EV is changing the game, and that way robotics is very interesting. But a lot of these form factors that we have in these STEM products tend not to be as exciting as the realities of the space. Whereas with rockets, what happens is that they don't represent just rockets. They represent space exploration as a whole. And that way, space exploration is something which humanity has yet to sort of really get into.
Yeah.
And so that way they are, I believe, way more exciting and way more inspiring than most of these other tools at our disposal. And we have some of the most intelligent kids out there in our country. They're amazing people. So we definitely need to show them the opportunities and possibilities that they can learn, and they can do a lot more interesting things.
Yeah, absolutely. And so when you started Rocketeers, during your time at IIST and then Rocketeers, from being an academic to like being a commercial company, you talked a lot about regulations, rules, and so on. Did you have a sense of what were the rules and regulations back in IIST, and did you have a sense of it when you went to Rocketeers? And because of the sense of regulations, did the design change drastically? What was your experience?
So I had no idea about the regulations in IIST. I knew for a fact that there are no regulations, which I still know, and which has always held true throughout it all. There are no regulations when it comes to rocketry. But if you want to look at it at a very core level, there are regulations centered around fuel. Because fuel is an explosive sort of material, and there is a Department of Explosives that regulates explosives. But there are no regulations around rocketry. So there is nothing talking about using this fuel for rocketry. What are the rules and regulations if I want to fly a rocket? Do I have to get a permission from someone, or can I just fly it? Can I fly big rockets? Can I fly small ones? Where can I fly them? What are the safety precautions that I need to take? Are there any specific restricted areas, or are there any specific designated areas that I can fly at? None of these things exist in our country. And initially I thought that so I found out about most of these things after I sort of started Rocketeers. This was the time that I was studying to understand what to do commercially and what we can and cannot do. More than this, the problem that I did not realize, which really impacted us, say in about 2017-18 era, was the fact that I had naively thought that I would be able to impact regulation without critical mass. Which was something that I did not understand about regulation at that point of time, which now is forms a lot of impact on both product design and business strategy as well. So because of that, I used to try and affect a lot of regulation change. I used to go and meet the regulators. I used to talk to them. I used to tell them about what we are doing, what we aim to do, and how we can create conducive regulation. They all used to listen to my ideas. I wouldn't say that they were not receptive. Some of them were actually excited by them, and they used to discuss them with me, and they probably would have pushed paper whatever they could have pushed. And I met people from the highest levels to the lowest levels. I did not discriminate in terms of any regulator. I was like, fine, doesn't matter whether change can be impacted through that specific person or not. I will just go and educate him. And I held a lot of meetings in that 1.5 2 years with these people. And I never really heard them tell me that they would want to ban rocketry or they would not want to regulate it. That was never the perspective. The perspective always tended to be that this was something that was not important on their table. They had a lot of things, each and every regulator, that they had to do as a part of their job, which were important, which were on priority. Either they impacted. So if these were very high level bureaucrats, then they had stuff which was related to, say, agri or mining industry or petroleum industry. So they have, and these are impacting large group of companies, large number of people. So they have to look at that first before they start looking at just one startup doing something. So it has to be an industry play. Even with drones, drone regulation was impacted because there were a large number of companies who were doing a lot of things in different sectors, from defense to civil to imaging to toys to whatever. And that's when sort of regulation happened. And if I met the low-level bureaucrats, they may not have a lot of stuff on their table to not be able to look at my proposal, but then they couldn't impact change. They were not in that position. That changed a lot of things for us, because that's when we started really exploring on trying to create this critical mass and trying to keep the government involved in this. So what that has led to is a lot of very, very interesting things. We have partnerships with Niti Aayog, where we are doing Atal Tinkering Labs. All of them have model rockets in them. We are working with the government of Telangana. Their BC welfare residential schools now have model rocketry labs in them. We have been in lots of talks with DIBP and Invest India. So we've actually been awarded by them at GES as one of the top 80 Indian startups. Apart from that, they call us to various regulation roundtables to keep this topic of model rocketry and regulation in play. We have managed to generate some awareness about this in the political circles as well. We've generated a couple of parliamentary questions. We've kept ISRO in the loop. So ISRO last year, when they were this year actually for the Vikram Sarabhai centenary, they were planning some educational programs. So at that time they had talked to us about how rocketry works and all. I don't know what they're doing. They've not really engaged with us, but they gathered some information. So even they have been getting educated about model rocketry and how it's happening in the country. So that's how we're getting government involved, and we're getting awareness through. I think that's what's important. And when there happens to be 5 lakh model rockets flying across the country, I'm sure regulation will happen, and we shall keep fighting for that critical mass. That's the whole idea of Rocketeers. The vision is to create this rocketry ecosystem in the country.
When it comes to now, what is the engagement like? How are you spread? How do you reach out to people?
The engagement is in various different ways. I would say there are 3 primary things that we do. One is that we set up rocketry and rocket propulsion laboratories. This is, I would say, rocketry for schools, rocket propulsion for colleges, which intends to be a little more centered towards propulsion. The second thing that we do is that we do rocketry hardware sales. So we have created a lot of rocketry hardware, from model rockets, DIY kits, components, fuel cartridges, ignition launch systems, test apparatus, and this is an expanding range. So we're always coming out with sort of newer and improved versions. We're planning to do electronics based payloads and buses very, very soon. So it will be like an instrumentation panel that students can attach their own sensors to. We'll provide a data acquisition system with it as well. So things like that, and we let anybody and everybody who wants to do that and at their own way. So what we do is that we provide training and curriculum for how to use the hardware, but then what kind of experience people want to build around it sort of depends on them. This is how most STEM companies are using our sort of equipment, and I'm very happy to say that I see very strong traction there, in the sense that almost all our clients are recurring. So once they get the hang of rocketry, they understand the fascination part of it or the excitement part of it, it really gets to them. So I've had these companies who used to do robotics, or who used to do planes, or who used to do 3D printing, and they were when we started talking to them and we told them about rockets, they were fairly hesitant because of lack of regulation and how this will work. We don't know rocket science. Can we teach this? Can we will be able to build this? Will we be able to create any kind of educational experience out of it? But once they start, they keep coming back for more. And so that way that's the second sort of major thing, and that's what I think will really build the ecosystem, because these are the people who take it to so many other places and who do this in their own different ways, and we have partners for this across the country popping up now. And the third final thing that we do is sort of workshops, training and consultancy, where we have our own team coming in and teaching people and training them, which is sort of the service segment of this whole industry. So we try and keep that as minimum as possible, because the idea is that for us is that we want to enable people to do rocketry on their own. We don't want to spoon feed everything to everyone.
And from, let's say, the kids' perspective, or the young people perspective, did you have already some stories of people?
Oh yes, some very very interesting ones. So this one kid that I know, his name is Ritik Soni. He's in a tier 2, tier 3 city in UP. And he is currently, say, in 9th or 10th class, and he builds his own rockets, and he has done some very very interesting work. He's built sugar motors of his own, and he keeps talking to us about building these new things. And since he started building these rockets on his own, he has now further taken this as a physics training activity across schools around his sort of region, which I find so interesting, that he is himself on his own time, on his own cost, going to these schools and talking to these students about physics and about how it is interesting, and flying these rockets in front of them. And that's exactly what sort of is so inspiring about this whole thing. Another student that I know, his name is Nabhan. He's in Bangalore. He's also been doing some super interesting stuff. He's more inclined towards the payloads side of it. So he's not flown many rockets like Ritik, but then he has built a few, and he basically concentrates on putting them interesting communication payloads in them. He's developed his own sort of chip for short range communication at very high bit rates. So some interesting things, and students get very very interesting ideas, and it's super exciting to see them sort of start pursuing this as an activity on their own once they do start getting opportunities. And interestingly, the very problems that these students faced, we've been sort of targeting exactly that. For example, Ritik used to say that I'm able to make the rocket and everything. I can even sort of make my fuel, but while after my fuel is cured, I don't have any sort of safety gear for handling it, and I have no way to procure it. I don't have the right safe igniters. I build my own igniters, but they are very unsafe. They may lead to a burst and an explosion rather than a series ignition for the core. We've been able to solve them. So we've provided these students with safety gear. We've provided them with proper igniters. And the interesting thing about these exciting students is that since they're so experimental and they're always trying out new things, they can always even help us out with experiments that we want done. So we try and support enthusiasts like this. In terms of hardware costs, we sort of bear it on our own, and we sort of want them to go out and do these kind of things. Another very interesting example is Anudeep. Anudeep has been doing rocketry for more than 6-7 years now, and with our kits now, he's sort of taking rocketry to villages around his city near Vijayawada.
Okay.
So he has done approximately 70-80 rocket flights in the last 2 months, where he has gone to villages and in schools over there told students about rocketry, flown rockets in front of them and shown them. So when he used to build his own rocket, he used to say that my cost is around 15,000, 16,000 for one rocket. And we are so first few we did for free, but then now that he's scaling up, we thought that there's only so much we can do, and he can charge the students a little bit. So that way we try and keep it, at least these outreach activities try and keep as accessible as possible. That's the idea. But yeah, super interesting. And now that it's becoming accessible for people, and then we see a lot more traction, as I told you earlier also, that this year we see a lot more traction, because now it's suddenly much more visibly accessible, something that they can buy into.
In that sense, you are bridging a lot of gap that is left in the education system, because our typical education system, regardless of even in cities today, I guess, is very bookish, not much of hands-on stuff, and especially if educators themselves, teachers themselves are not trained in rocket science or rocketry or model rocketry, there's no way of them teaching that to their kids at all.
True.
So you're filling a large gap there.
So I have been very pleasantly surprised about this over the last 2-3 years because of two major factors. One is that the direction that we're moving in is correct. We are now understanding at a very, very ground level. Like, I can see this in schools in tier 2 cities, villages, in towns, and in big cities, in the rich schools, most definitely it's quite prevalent, where we have started understanding that the bookish knowledge and the memory aspects of studies and how marks and mugging up used to be important when we were in school, that's not really the thing that's important anymore, and we need to start concentrating more on project-based learning or problem solving, or giving the students an opportunity to basically think themselves. That used to be the major problem on our education system, where we were not allowed to think, because we were supposed to do what we were told, and that was it. So that is changing. That perspective is changing in the teachers, and a lot of this has to do with a lot of new things that have come up in terms of STEM education. So Atal Tinkering Labs has obviously been a game changer in terms of schools at understanding and appreciating this sort of education system, because this is the first time government is sort of pushing it and telling them that, okay, now yes, you are doing all these mugging up and you're doing this in a certain way, but you need to at the same time sort of teach the students to think on their own, to tinker, to innovate, and to sort of look at problems and look at problem solving, do critical thinking, do creative thinking. So that's one thing that's sort of happening, and it's becoming more accepted in schools. It may not be visible in terms of a lot of impact right now, but it's a slow change, but it's a change in the right direction. So that makes me happy inherently that, okay, at least this is something good that's happening, and as it grows, I'm sure momentum will grow. The second thing that really is even more sort of profound and impactful than this is that the new modern education tools that we are developing, and I want to put screens out of play as much as possible. Screens are necessary beyond a certain point, obviously, because screens provide the world's information at a fingertip, and that's not available without a screen. But keeping that aside, the tools that we have, the hands-on tools, the things like robotics equipment, the things like those drones and those gliders, and say, for example, our model rockets, or 3D printers, or anything and everything, they are becoming more and more intuitive. They are becoming tools and things which students use and can learn on their own without guidance. So that is profound, because if you leave a bunch of students, if you leave a class of 30 students free to do whatever they want to in an Atal Tinkering Lab, say for example, that lab has a bunch of things, a bunch of tools available. These are all hands-on. There is no board, there is nobody teaching them, and you tell the teacher just to go and sit and chill, and you do this 1 hour every week for, say, a group of students in 9th class, 10th class level, and the students will learn all of these things on their own. That may not have been all that possible earlier, because these tools were not as intuitive, but now they are being designed with that in perspective. They are being designed to teach students. So now the PCBs or the electronic components, kits that people design, they are designed with intuitiveness in mind. It tells the student that this is how you attach the sensor, this is how the sensor works, and so on. Same thing we do with our model rockets. Our model rockets are designed to be very intuitive. So you will be, if I give you a bunch of parts, you will be able to build it, and you will be able to fly it. So that is also creating a lot of impact, because it puts the teacher out of play a little bit. The teacher needs to obviously teach them about the physics and the theory of it, or the science of it, or the terminology, to say the least, and that's where sort of screens also come into play. But it really provides an opportunity for a lot of schools who may not have access to the right kind of teachers, who may not be able to even have access to the right kind of training for their teachers, and this tends to be a major constraint, and this constraint we can sort of push beyond, even without, so it's not the conventional way to solve this problem, but then it is solving this problem.
The current trajectory that you are on already, right? You have a lot of momentum going further. You've created all this ecosystem coming together. What do you think is the ecosystem like 10 years from now for model rocketry in India? What is the kind of reach? Do you see more people participating?
Oh, I definitely see a lot more people participating. We have barely scratched the surface. So I see, even 5 years from now, I see more than 1,000 rocketry labs across the country. I see, so let's forget about just pure numbers, but I see a spread out of the activity. So right now it's sort of concentrated in pockets and silos. It will become more ubiquitous. We will have designated flying zones. Secondly, we will make it we will see a lot more activity in terms of competitions, in terms of this driving human resource creation, which will feed the space industry. So this we already see happening in other sectors in our country. For example, if you look at the automotive sector, we have a very good, highly evolved automotive sector with big names like Tata Motors, Mahindra, Ashok Leyland, Bajaj, Maruti. All these people employ thousands and thousands of people, and don't even get me started on the ancillaries after that. It's a massive impact, economic impact. Now, if you go into the human resource of these companies and you talk to people, especially the engineers across the board, you will see that more than 60-70% of these engineers had participated in SAE or related events and competitions in their time in college. And that's what sort of connected them to the industry, and that's what sort of that was the first stepping stone of sort of building the skill set that is necessary for growing in this sector. And we will see that exact same happening for the space industry. So space industry is a little more multifaceted than the automotive industry, where we have rockets as one thing and satellites as another, and then the application side of it as a completely separate segment. So and the skill sets required in the three are very, very different. But if there is one thing that is true, it is the fact that rocketry is what is the glamorous aspect of space industry. It's what gets people interested. It's what sells the story of space technology. The fact that we can communicate using satellites and we can have a very, very high resolution pics of all of our Earth, or we can watch the stars better, or all of these things is not what sells the story of space or space technology. What sells the story of space and space technology is exploration, and that is always connected with rockets. The bigger, the better the rockets, the more the exploration. That's always been our constraint, and that's what sells the story. And that way, if we keep that part missing from the ecosystem, we will never be able to create the human resource pool necessary, because we will not have large number of people interested or inspired enough to participate. And I feel that is what rocketry will be doing 10 years from now, and the students who we are connecting to now are going to be the people who will be driving this change, and who will be showing the space industry at that point of time that yes, we did rocketry when we were children, and that is when now we are building satellites, now we are building space habitats, now we are building robots which will go and mine asteroids, and now we are taking our humanist values to other planets and moons and doing all of these interesting and dynamic things 10, 15, 20 years from now. So we have to capture and inspire them young, and that's what rocketry will be doing 10 years from now. Right now it's just sort of scratched the surface. It's just beginning.
My last question to you is, how can I buy one of your rockets?
Oh, you can visit our website directly, www.rocketeers.in, and we have all our rockets, all our components, all our systems, everything available online directly. And as I think I iterated what all we provide. So and you can reach out to us directly on our website if you have any further queries, if you want to do something else. We are always looking to explore, trying to do new things with this, since this ecosystem is so raw in the country. We have lots of interesting new things that people come up with and do with this. For example, there are team building corporate workshops that now happen around rocketry, which was a shock to me as well. But yes, there are 50-year-olds who want to build these rockets and connect with their young children, and so some things like that happening, and obviously the learning and education side happening. Enthusiasts are a game of their own. So all of these people are also sort of getting a platform to connect on our website, where we have a public open blog. So we have all of these ecosystem players coming in and contributing their experiences. So you can read about these stories on our blog, and you can get to think about what kind of ideas people have about rocketry in the country, and give us feedback.
Divyanshu, thank you very much for taking time for doing this.
Thank you, Narayan. It was a lot of fun. It's always nice coming and meeting space friends again. They are the ones who inspire me to do this.
Thank you for staying until the end. If you have any comments or suggestions, please write to curator@newspaceindia.com. Please consider sharing this episode with any friends or family who may be interested in learning about India's space activities. If you would like to stay in touch with the NewSpace India community, please use the link in the description to join the NewSpace India Telegram group. Feel free to also suggest guests for any future episodes. A new episode of the NewSpace India podcast is released every other Friday. Do subscribe to the podcast using Apple, Google, or any other podcasting platforms you may use. Thank you.